Okay, good evening. Am I audible?
Good evening, sir. You're audible.
Voice is not coming. Could you repeat?
Good evening, sir.
Okay, yeah, it means that I'm audible. Great.
Yes, sir. You're audible, sir.
So, do you have any doubts?
No, sir.
No. Okay. So let's start with our first thing. Till now, you may have already read what is written on the screen about function, odd function. So, odd functions. Okay. So, okay, sorry for inconvenience. Actually, there was some technical problem. Okay, so is the screen visible now? Is my audio low? Yes. Is my audio and video properly audible and visible?
Yes, sir.
Okay, so let us now proceed with further discussion. Okay, so first talking about odd function. A function f is odd if f of minus x is equals to minus of f of x for all x in its domain. It means that whenever we will input some negative value of the variable to the function it is going to be equal to minus of function, which is like for the positive value of the function. Okay. And for example, we can take the example of x of q. We will put x value like -1, if you will put let's say x is equals to -1, then f of -1 is going to be equal -1 raised to power 3, that is -1. So one otherwise if we would have put it +1 into the function, so it would have been equal to 1. So we can replace 1 with f of 1. So here in this case, for f of -1, it is coming out as minus of f of 1, f of 1. So this is an example of odd function, and this condition particularly should satisfy for all values of x in its domain. When we talk about even function, these are the function when we will input some negative variable and the function will be equal to the function, the output when some positive value of variable would be put it into the function, would be substituted in the function. Okay, so this is even function. For example, x square. For x is equals to +1 plus -1, f of +(-1) would be equal to f of +1, and it is going to be equal to f of -1. Okay, so that's why we are saying it as an even function. It does not matter what sign of the variable is, it is just going to treat the variable same in the same manner. Okay, it isn't, it is, I'm not saying that there will be positive output of the even function, not every time, because even function is also this f of x is equals to minus of x square. This is also known as even function. Why? When we'll put like some negative value of minus of x, then minus x square is going to minus x square. So this is also like negative value, and but here we can see that f of x is equals to f of minus x. That's why we are calling it an even function, because the sign of variable does not matter. Otherwise, we are not talking about the sign of overall result. We are talking about the significance of the sign of variable. So this is about even and odd function. Are you able to understand it? Yes. Am I clear?
Yes, sir.
Please keep on responding. So yeah, about differentiation chapter, there are two properties. The derivative of an even function is odd function. Okay. The derivative of an odd function is even function. Okay. Odd function. And the derivative of an odd function is an even function. That's it. So let's now discuss the first example. Uh, have you learned all the differentiation formulas? Hello.
Yes, sir.
Great. It will help you understand well while I will be solving these questions. So here the given function is f of x mod of x minus 2 mod of x minus 2 and g of x as f of fx. Then the value of z dash x, which is the derivative of zx for x is equal for x greater than 20. So here in this condition, we can understand this function and we can represent this function as 2, like x plus of x of minus 2 and minus of x minus 2. When for all values of like, let us first understand and equate this particular function x of minus 2 equals to 0, because on 0 it will be changing its sign. So x of minus 2 being equal to being equal to 0. So like what is the domain of this particular function? Here we have to put certain value, like for f, for is it's this modulus function come for this modulus function expanding is positive as it is. For that we need to have some positive expression inside this modulus. So this will be positive when it will be greater than 0. So for all values of x which is greater than 2, our function will manifest itself as in the same form. So like this. And for all values of x minus 2 being 0, there will be minus sign in front of the function's expression. Okay, so are you able to understand how have I expanded this particular function?
Yes, sir.
Great. Continuing our discussion, as it is given in the question that we have to discuss about for all values of x which are greater than 20. So if it is greater than 20, then x is also greater than 2. So we are going to talk about this function. So our function becomes x minus 2 for x greater than 20, which is given. Okay. So z of x is f of x, f of fx. What is fx? X minus 2. And later on, further substituting the value of x of minus 2 in this function. So that it will become at the place of x, we will substitute it with x minus 2 minus then 2. X has become, sorry, okay. So x has become x minus 2 and minus 2 remains the same. Okay. That's how we have written it. Later on, it will become x minus 2 minus 2, x minus 4. So z of x is x minus 4 for x greater than 20. Now let us differentiate z of x, and it is differentiation of x will be what? Unmute yourself and say differentiation. What will be the differentiation of x minus 4? Differentiation of x will be 1. Differentiation of 4, that is the constant. The differentiation of constant is 0. That's why minus 0. So it is 1. The answer will be B. If you are not able to understand the basics of differentiation, you can ask me unhesitantly and I'll repeat them. Should I? Should I repeat?
Sir, I couldn't hear you, sir.
Should I repeat?
No, sir, it's clear. I just
Okay.
got some issues on my phone.
Okay. So if I'm not clearly audible, let me place my laptop a little closer. Am I clearly audible now?
Yes, sir.
Okay, so let's move on to the next example, which says, which we have a example of inverse trigonometric function. So let's in this question, we are given with a function and we have to find the derivative of the function. Then later on, we will substitute, like first we will find f dash of x, and then we later on will substitute the x with equals to 1, which is given in the question, for which the value we have to find out. Okay. So let's now first of all differentiate this particular function. And as we know, differentiation of cot inverse of x is minus 1 upon 1 plus x square. Okay. So here we will apply the same, as there's another function in the variable in the input of cot inverse trigonometric function. We have to further differentiate it. Okay. As we have discussed earlier also, chain rule. So it is the same. We are having a function that is like this is a cot inverse trigonometric function, and we are having different function inside it. So first we will differentiate it, and then later on we have to differentiate it also, like the function which is inside the cot inverse. Okay. So we are doing the same, we are applying the same concept as of chain rule. So differentiation of cot inverse f dash of x is 1 minus 1 or 1 plus x square. What is x square? X raised to power x minus x raised to power minus x upon 2 its square. And I believe that we have already discussed about logarithm differentiation. Yes, here we have discussed about differentiation using logarithm, where we had a function, a raised to power function. What is a function? Which is having a variable of our concern. Our concern variable is what? This variable, which is x. So here in this question, we are seeing functions like this, functions like this. So here we have to also apply logarithm differentiation using logarithm method. Okay. So coming back to our question. Yes. So as we have discussed earlier, first we have to differentiate this whole function. Now later on we have to multiply it with the derivative of the variable which is inputting in the inverse trigonometric function. So if we have to differentiate it, first of all, in the denominator there is 2. So it is coming out as it is, because it is a multiple. It is a constant multiple with the function. Now we have to differentiate x raised to power x minus x raised to power minus x. Earlier we have discussed about that how we differentiate function who have function raised to a function. So let us consider this as u, let us consider this as v, and discuss it one by one. Du by dx, that is d by dx. Okay, so continuing, we will have to take logarithm first. So as u is equals to x raised to power x, taking logarithm on both sides, log of u, logarithm of x raised to power x. So it will become logarithm u. This will come ahead, log x. And now we will have to differentiate both sides with respect to x. Okay, as u is a function of x, this is x, this is also x. As u is a function of x, so while differentiating logarithm of u, it will also be differentiating with x. It is not a constant value as it is a function of x. So logarithm of u will come out as 1 by u, and into differentiation of u with respect to x. This is what? This is x. We can use, if there are two functions in product and we have to differentiate the product, so we have to apply product rule, which says u dash v. We have discussed it earlier. U dash v plus uv dash. Okay, so here u is what? X. Differentiation of x is 1 into logarithm of x plus, this is u, this is v. Differentiation of logarithm of x is 1 by x into x. It will become as 1 plus logarithm x. We have to find out du by dx, right? So we will send u to the right hand side. So what we had earlier, du by dx, 1 plus logarithm x. So du by dx will become u into 1 plus logarithm of x. Okay, so what is u? U is x raised to power x into 1 plus logarithm of x. Similarly, we can find out for v, which is x raised to power minus x. I'm sure. Yes, it is the case. So let's take logarithm on both sides. Are you able to understand why I have written minus x in front of logarithm of x? Because it would be its exponent, then it would come out in front of that logarithm. Okay. Now what we have to do is we have to take the differentiation of this equation. Logarithm of v, as v is a function of x, so we can differentiate it as also this is not a constant with respect to x. Differentiating logarithm v, it will become 1 by v into dv by dx. Differentiating it, we will have to apply the same formula, that is product rule. X log x 1 into logarithm of x plus x into logarithm of x with derivative, which is 1 by x. This is 1 now. So 1 by v into dv by dx. dv by dx minus the logarithm x plus 1. So dv by dx comes out to be, v is what? V is x raised to power minus x. Write it as x minus x raised to power minus x into the multiple of negative into 1 plus logarithm x. So now we have the derivative of both this and this. So now we can write their derivative here with minus sign, write their derivative here. Okay, so let's do that. Bring this ahead. So here we have to write the derivative of this, which is what? X raised to power x into 1 plus logarithm x minus differentiation of this, which was what? Minus x raised to power minus x into 1 plus logarithm x, right? So now as we had to find out for x is equals to 1, because it is what that is asked in the question. We have to find out the value of f of dash 1. As we have already found out f dash of x, now we'll simply substitute x as 1. Okay. On doing that, we'll have f dash of 1 minus 1 plus 1 raised to power 1, that is 1, minus 1 raised to power minus 1, that is also 1, by 2 square into x raised to power x 1 1 plus logarithm of 1. What is log of 1? Please unmute yourself and tell me. Please tell me what is logarithm of 1. Okay, so logarithm of 1 is 0. This will become 0. This will become 0. Okay, and this minus 1 minus 1, it will also become 0. So what effectively answer we are having is minus 1 into this 1 plus 0, it is 1 also only. So 1 into 1, 1 minus minus 1 into 1. So that is minus 1 upon 2. Okay. So has we made any mistake? No, we have not. To see it again. 1 raised to power minus 1 is 1, 1 minus 1, 0. 1, 1 plus logarithm of 1 minus 1 raised to power 1 into 1 plus logarithm of 0. That's minus 1, 2, 0. Okay. So minus 1 into 1 minus 1 it will become 1 plus 1 by 2. 2 goes, and our answer comes out to minus 1, which I suspect is the wrong answer. Let's see if there's any option. Yes, there is an option. This is the correct answer. Yeah. So this is the question solution. What we have done, let me summarize it. That there is inverse trigonometric function, and whose variable is also a function. So we had to apply chain rule, and first we took the derivative of this complete function, and then we had to multiply it with the derivative of this variable function. After doing so, after finding this f dash of x, we have to substitute x for x is equals to 1 because that is what we have to find out in this question. And we have done that particular thing exactly, and we have got our answer. Okay, so is everything clear to everyone? Is that so?
Yes, sir.
Yes, let's move ahead then to our example number 3. So we have to find out the derivative of this function, which is in the form of numerator and denominator, and we had to apply this formula which we learned earlier, where u and v are the function of x. So its formula was, okay. So let's apply the same logic. F dash of x to u dash v. What is u dash? That is x square. So 2 will come ahead. X is for 2 minus 1, that is 1. Okay. Into v, 1 minus x square minus u into v dash. The derivative of this particular, we are calling it v, we are calling it as u. So the derivative of this is, one's derivative will be 0, minus x square derivative will be minus 2x. Okay. Are you able to understand that why I am writing so? Now the v square. Please unmute yourself and keep speaking. Minus minus, it will make it as positive. 1 minus x square. So a minus b whole square is a square plus b square minus 2ab. Okay. So 2x minus 2x cube plus 2x cube upon, what is this? 1 minus x square. Let's keep it like that because the answer is in this form, this form, this form. So it will come out, it will cancel each other, and 2x by 1 minus x square raised to power square. This is our answer, which matches with option number B. B is the correct answer. Okay. Is this question clear to everyone?
Yes, sir.
Yes. So now I'm going to ask some questions from you all because everything is clear to you. So let's check how much clear. Okay, so you have to ask, you have to answer one by one. First of all, starting with Rishi. Rishi, tell the answer of this first. Rishi, unmute yourself and tell the answer first. Otherwise, I'll mark your presence in the class as absent in the attendance. Rishi, are you there? I guess he's not there. Nandana, can you tell this
Yes, sir.
first? Yes.
4x power 3.
4 into x power 3. Good. Rishi, if you're there, please tell about this one. No, he's not. Yes, Nandana,
Sir, 5x power 4.
are you sure?
Sir, with respect to y,
So what it will be? See, as we differentiate particular function with respect to some variable, है ना? We differentiate all the function, like if there is any function, and if we are differentiating it, so it will only equal to some number other than 0 if it if the function is dependent on the variable. What is the variable here we are discussing? That is x. So if the function is not dependent on x, is the slide visible to you? Like, is my screen visible to you? Is that is is what I am जो मैं लिख Is my screen visible, everyone?
Yes, sir. Yes, sir. It's visible.
So what I have written is the ink which I am using green right now. Is that particular thing visible to you all?
Sir, it's visible, but if it will be better if it is any other color.
Okay. So here the problem is this the function is not depending this x raised to power does not depend or does not change when y changes. So this function does not care whether y is changing or not. So the differentiation, so the change in this function with respect to y is 0. Okay. Because this function is not dependent on variable y, with which respect we had to find out the derivative, right? So let's now talk about the third function. Now tell me what is its answer.
Sir, is it a power x?
And
Log a.
yeah, I guess Rishi को एक और मौका देना चाहिए. Let's give one more chance to Rishi. Rishi, tell me the formula of this. Rishi, are you there? He is absent. Anyways, can you tell this? Can you tell the answer, Nandana?
Sir, it's 0.
Why 0?
So because it's respect to y and we have the
Right?
we have x in the power of e.
And yes, so we have x as a variable in the function, whereas we have been asked to differentiate the function with respect to y. So with respect to y, our function does not change. That's why our differentiation and the derivative is 0. Okay.
Yes, sir.
Okay. So let's now talk about differentiation of function in parametric form. Yes. So here these are two functions x and y, where t is a variable. T is a variable. Okay. So we have a function x and y as represented, and we had to find out the change in y with respect to x. We have to find out the change in y with respect to x. Okay. And but the problem here is that it will not be 0. Why? Because y is depending on t, and sorry, y is depending on t and x is also depending on t. So when we will change x, when we will change x, so y will also change, because y is also dependent on t and x is also related to t. So if we change x, then t changes, and if t changes, then y changes. That's why there will be some derivatives finite value and will not be equal to 0. And how we should find out the change of y with respect to x is given in this formula. Okay. Here we can see this formula dy by dx, that first we have to differentiate dy with respect to dt, and then we have to divide it by the derivative of dx with respect to dt, and later on it will be equal to dy by dx. Okay, this is the case. This is the differentiation of function in parametric form, where there is a parameter t which is common in both function y and x, and due to that there will be certain respective change in y when we will have some change in x. Okay, is that clear? So if there is a certain question based on this, we are also going to discuss an example by which you will be able to understand this concept in a more clear way. Okay, so just remember this formula, that whenever we have two functions which are dependent on a common parameter, then they will their differentiation, that there will be some respective change in between those two functions. Okay, let's now move on with the first example of this question. Okay, so dy by dx, we have given x as a function, y as a function, whose parameter is theta. Okay, this is a common variable between these two functions, and we need to find out change in function y with respect to function x. So as we know that y is depending on theta and x is also depending on theta. So if we will change x, then there will be also some change in y, and that we have to find out the respective change, the instantaneous rate of change. Okay, so let's for that, for finding dy by dx, as we have to find dy by dt, sorry, d theta here, because theta is the a common parameter, and dx with respect to d theta. So let's move on with finding dy by d theta. So it is what? A into one's derivative, it will 0, minus cos theta's derivative will be sine theta of negative sign, which will make it as positive. And what we have done it here, that this is a constant. Okay, this is a constant. And how we get to know that theta is the parameter here? So theta is the variable in both of these two functions. Why it is not a? Because in the question, in the options, we can get an idea that theta must be the variable. Okay, so if it is a constant, we are multiplying constant with some certain function, and we are derivating it. So we can write it as c into derivative of f of x by dx. So we have written constant outside, which is a, and we have further differentiated the function, but as theta, as this one, sorry, as the function, the constant being the outside, and one's differentiation being 0, cos theta differentiation being this. Yes. So it comes out to be a sine theta. Now solving for dx by d theta, x is what? A into theta minus sine theta. So a is a constant. Let's keep it outside. For theta, d theta of theta is 1. D theta, so d sine theta with respect to d theta would be minus, sorry, cos theta. And it will remain as it is, 1 minus cos theta. So to find dy by dx, we'll just put the values a sine theta a upon 1 minus cos theta. So a cuts a, dy by dx is going to equal sine theta upon 1 minus cos theta. When we will discuss trigonometry later, then we'll come to know about certain formulas more. For now, let me tell you the formula. Like sine 2 theta is 2 sine of theta into cos theta, and cos 2 theta is equals to 1 minus 2 sine square theta, or we can also write it as 2 cos square theta minus 1. But we have to discuss this for this case. So sine theta is what? 2 of sine of half of its angle, because this formula is for 2 theta, and that's why theta is there. So the half angle is there. So here, if it is theta, so we'll take the half angle. Cos theta by 2, 1 minus cos theta. So let's tweak this formula a little and write it as 2 sine square theta equals to 1 minus cos 2 theta. So, okay, 1 minus cos 2 theta, 1 minus cos 2 theta is equals to 2 sine square theta. So, 2 sine half of what the angle is here. Okay, yes. So, 2 sine square theta by 2. 2 will cancel 2 and sine theta by 2 will cancel the double power of sine theta by 2. Now it will become cos theta by 2 by sine theta by 2. Cos x by sine x is what? Cot x. Cot theta by 2 is our answer. It is in the option yes. Okay. So is this question clear to you, everyone? What we have done in this question, there were two functions given, x and y, where x was depending on theta and y was also depending on theta. We had to find out the change in function y with respect to the change in function x. So what we have done, first we have found out the change in y with respect to theta, and we divided that the change in x with respect to theta. Okay, so this is how we have approached this formula, and this particular formula we have used, and this is how we have approached this question. Okay, is the question solution clear to everyone?
Yes, sir.
Great. Is there much background sound from my side? Okay, so let's discuss differentiation of implicit function first. Before discussing that, let us first understand what is explicit and what is implicit function. An explicit function is an algebraic function in which the output variable, the dependent variable, can be written. First, let me tell you what is dependent, what is not dependent. Let us say y is equals to x square. Okay, y we can also call y as a function of x, right? Which is x square. Okay, so here if we see that this is independent variable. Okay, I've written it wrong. Independent variable is this, because this is independent. This is of our choice. What will come as y, it is a dependent variable, and it is depending on what? It is depending on x. Here y is depending on x. That's why we are calling y as a dependent variable, and x is an independent variable. Okay, because it's a input variable. It is also mentioned here. Output variable is dependent variable. Okay, because what is coming out is dependent on x, and x is not dependent on any other variable here. So x is an independent variable and y is a dependent variable. Now let us understand, an explicit function typically has two variables, dependent and independent. It is more clearly expressed, making it easier to determine the values of the variables in an explicit function. Okay, where we can actually and easily calculate separately the value of x and y, whereas in an implicit function is one that cannot be written as one variable in terms of the other variable. This particular function which we have taken as an example is an explicit function because of why? Because we can write a certain variable equals to some other variable. They can be separated easily. That's why they are known as explicit variable. But if we will take it as like y of sine of x, and we take this bit. Okay, now, if this is our function, so this is an implicit function. This is implicit function because we cannot separate x and y, the the dependent and independent variable cannot be separated. Okay, that's why we are calling this function as a independent variable. Now let us read again. An explicit function is an algebraic function in which the output variable, the dependent variable, can be written explicitly, means
Sir,
separately, independent. Yes?
sorry to interrupt. I got the answer, sir. It's option B.
Okay. For this question,
Yes, sir.
it's option D.
Option B. Minus
B.
2 of plus 5.
Okay. Let's check that later on when we
Yes, sir.
discuss. So that's great.
Thank you, sir.
So yeah, focusing on our discussion that explicit function in which that we can write those two variables independently in an explicit form. Okay, so I've seen that you have got the answer, and for this example, we cannot differentiate and we cannot separate x and y with equal sign. We cannot write y in one hand side and x on other hand side. Okay, so let's now discuss this formula, that how we are going to solve for implicit functions. So we have to do nothing, just we have to just write it as it is given, and then we have to differentiate both of its side. So, and we are differentiating with respect to, sorry, with respect to x. Okay, so x square will become 2x and plus 2. Differentiation of x and y, we have to apply product rule here. So differentiation of x 1 into y plus x into differentiation of y will, which will be dy by dx, plus a differentiation of y cube plus 3y square into differentiation of y dy by dx is equals to 4. The differentiation would be 0. As we have to find out dy by dx here, right? So we will take dy by dx on the one side, and other variables will remain on the remaining side. So let's now first further simplify it. Let's bring the remaining values other than which are attached to dy by dx to the right hand side. Okay, so let's bring them first to the right hand side, 2x minus 2y, and other than these terms are directly attached to dy by dx. So let's take dy by dx common, write 2x plus 3y square. Further solving it here, dy by dx is equal to 2. Let's take minus 2 as common, minus 2 plus x plus y, and it in the denominator. It matches our B option, which is the correct answer, and it was also given by Nandana. Very good. So is this example clear to you all, everyone? So moving on to the example number 6. So differentiation of log of sine of x with respect to cos x. So there's a function given which depends on x. There's another function given which is also dependent on x. We have to find out the differentiation of f of x with respect to differentiation with respect to z of x. So what we will do? Simple. We will differentiate f of x, and we will divide it by z of x with x. Okay, because the common parameter here is directly x. This will be our solution. So let's now do it. First of all, let's take it as u. Let's take it as v. Okay, so let me simplify and write it. Okay, so as we are, okay. Yes. So we are taking this as v. So first of all, for finding it du by dv, we will first have to find out du by dx and dv by dx. Finding out du by dx first. Log of sine x. What is log differentiation of log? That is 1 by sine x into the differentiation of sine x. It is cos of x. Differentiation of x is further 1. So this is what? Cot of x. Differentiation of v with respect to x. Root of cos x. So 1 by 2 of root cos x into cos x differentiation, which is minus of sine x. Okay, so now finding out du by dv, simple, that cot x, which let's write it as terms of cos and sine x for better calculating, into minus of sine x into 2 into root of cos x, 2 into cos x to cos x root upon sine x into sine x, which is there's also minus sine square x. Okay, in the question we can see cot x and cosecant x. So let's make it as in the form of cot x and cosecant x. Cos x by sine x will make it as 2 cot x and into root of cos of x. Here there is a sine x remaining, so this will become minus 2 cot x into cosecant x, as 1 by sine x is cosecant x. Cosecant x into root of cos x, which matches our option number, which B. Sorry, C. So C is the correct answer. Okay. So this is all about today's class. No, there are 5 minutes remaining. So let's discuss some of if you have any doubt, then you can ask. Anyone? Any doubts? Anyone?
No, sir.
So we have started what we have done in this question. There are two functions. So we had to first solve for du by dx, du by dx. We have solved it separately here and here. Then we have put it its value, solved it in this direction, in this direction. Okay. So let's now discuss some important trigonometric formulas which you all are supposed to remember. Okay. So these are very, very important. You have to mug them up, and for the best trick to learn them all is by writing and by practicing this formula. So first you have to remember this formula, like three, make a set of 5 formulas first, 5 or 3. Okay, then remember this formula and uh, switch off your mobile wherever you are referring to these notes. Then go on your notebook and write these formulas and then check by yourself and remember in this method. Sine 2x is equal to 2 sine x cos x, and all these formulas are important also. Just not remember this also. Okay. Sine 3x is 3 sine x minus 4 sine cube x, or cos 2x formulas are really, really important. All these formulas are important, very important. Cos 3x, tan 2x, tan 3x. This is just a different representation of this formula, but you can understand it by writing theta in place of mx. Same goes with this. This is a manifestation, this formula, and some manifestation of this formula. This is also a formula which can be simply driven by tan of a plus minus b, where you will put a as pi by minus 4, b as x. And remember that when you will be doing that, this formula of tan a plus minus tan b upon 1 minus plus tan a to tan b. I am sure this formula is also written in the next slide. It is written in some other format, but yeah, you can also refer to trigonometric formulas to learn this formula. Okay, so you have to remember this old formulas Okay, so these are inverse trigonometric formulas. Learn them by heart. And here, if there's a inverse trigonometric formula, so the domain changes, and whatever the range for that trigonometric function is, that becomes the domain for an inverse trigonometric function. Okay, so you have to relate them accordingly and learn all these formulas. Okay, any doubt? Any doubt regarding this?
Okay.
Okay, so this is just to give you an idea that you have to, wow, spelling of idea. This is just to give an idea that wherever you see these terms, you can in inverse trigonometric expressions where you have to solve inverse trigonometric expressions and you have to differentiate them. Then if you see these terms, then you have to substitute x with the following. Substitute x with the following. Like if you see this a square plus x square form anywhere while solving inverse trigonometric functions, then directly substitute and let x is equals to a tan theta. And later on, when you simplify that function or that form, then you later on substitute x again and theta again with respect in place of x. Okay. Sorry. If later on after simplifying, the function will become in form of theta, then later on we can again substitute theta by taking value from here, and then the form will come out. We will see its example tomorrow. You'll be better. Uh, you'll be able to understand it in a better way. Okay, so you have all have to remember these. You will understand this by simply observing after you have remembered and learned these two slides. Okay, is there any doubt?
No, sir.
This is your homework, and please complete the other day's homework also, which was given. Limits p by previous year questions alone. Okay, so let's conclude our class. If you don't have any question to ask, is there any other doubt question regarding class? Any feedback? Any feedback?
Sir,
Yes, ask.
sir,
Tell.
no doubts.
Okay.
But the class is amazing, sir.
Okay, great. So let's conclude our class then. Thank you for joining.
Thank you, sir.